today we're going to cover section of our BU Press Algebra 2 textbook. This unit is over factoring trinomials. So our objective is to factor certain trinomials. So remember, a trinomial is going to be a polynomial with 3 terms. So we are looking at polynomials of 3 terms and how to factor them. So every trinomial of degree 2 or higher can be factored. You're only going to be asked to factor over the set of integers, and you should be able to do most of these with trial and error. I like to do the reverse box method. For me, that's the easiest way to see it. One way to help you do this a little bit faster is if you can recognize what we call perfect square trinomials. So let's go ahead and discuss what is a perfect square trinomial. Because if we can recognize it, then all we have to use is our formula, and we don't have to do trial and error guesswork. So perfect square trinomial has first and last terms, which are perfect squares. So first and last terms are perfect squares. The middle term is twice the product of the square roots of the first and last terms. All right, so let's see what that looks like. If we have a squared plus 2ab plus b squared, this qualifies as a perfect square trinomial. The first and last terms are perfect squares, and that middle term is twice the product of the square roots of the first and last term. The square root of the first term, a, the square root of the last term, b. So that middle term is 2 times a times b, where a and b were the square roots of the first and last terms. So what is this equal to whenever we factor it? Well, it's equal to a plus b times a plus b, which we can also write as a plus b squared. Let's say we have a squared minus 2ab plus b squared. This still qualifies as a perfect square trinomial. The only difference is that instead of being pluses, we have subtraction. And this becomes a minus b squared. All right, so let's look at some examples of recognizing perfect squares. Let's say we want to factor x squared plus 10x plus 25. So it might be possible that this is a perfect square. The first thing we want to do is we want to go ahead and rewrite the first and last terms and see if we can rewrite them as perfect squares. So x squared is already a perfect square, and 25 can be written as a perfect square. It can be rewritten as 5 squared. So now we just need to know, is that middle term the same as 2 times a and b? Well, x's are a and 5's are b, so we want to know, is it 2 times a and b? A is x, b is 5. Well, since 2 times 5 is 10, that works. Which means that it is a perfect square, which means that we can rewrite it using this formula. So that becomes x plus 5 times x plus 5, because remember, you use your a and your b, which is the same as saying x plus 5 squared. All right, let's look at another example doing perfect square trinomials. So we're going to look at example 2. Which says factor 4x squared minus 28x plus 49. So let's see if we can even make it look like a perfect square. So 4x squared can be rewritten as 2 squared x squared. And 49 can be rewritten as 7 squared. This 2 squared x squared can be rewritten as 2x squared. Now we need to check. Is this the same as 2ab? So our a is 2x and our b is 7. So 2 times 2 is 4, 4 times 7 is 28. So it does check. Okay, so we're good, which means that we can rewrite this as a minus b, because remember we have a subtraction here. So our a is 2x and our b is 7. So we have 2x minus 7 times 2x minus 7, which is the same as saying 2x minus 7 squared. All right, so as with binomials, there are several steps involved in factoring a trinomial. The main difference is going to be step 3. So let's talk about these steps in factoring trinomials. Step 1, we want to factor out any common monomial factors, just like we did when we were factoring binomials. Same step 1, we factor out any common monomials. Step 2, we check for special cases. Step 3, we factor by trial and error method, which I will show you with an example. It's basically reversing your box method. And then step 4, you continue factoring